kind of weird though, huh? Yeah, it's kind of weird. Yeah. Okay, so take any ray like that you have drawn, okay? And then what you want to do is let's take another ray, okay? And if I draw it over there, okay, what I want to do is I want to connect these two rays. So if I just drag this ray over here and connect them, oop, not quite right there. There we go. So if I put two rays together, right, they join at a certain spot. And the spot that they join at, we're going to call A. And this has a very special name. So the spot that they join at is called the vertex. Let's put two other points on our rays. I'll call this point C, and I'll call this point B. And the space that is made in between the two rays is called an angle. So all this space right in here is called the angle. So that is the angle. So an angle is nothing more than two rays that have a common point known as the vertex. And the other parts of the rays are just called the sides. Side there and a side there. So now that we know what an angle is, we have to know how to describe an angle, okay? So we can describe an angle using the angle symbol. This is the angle symbol that describes an angle. And there's a couple ways that we can describe this particular angle. We can describe it as angle CAB in that order, angle CAB. We can also describe it as angle BAC, so angle BAC. Or in this particular case, we can just call it angle A. All three of these are totally acceptable for describing an angle. Alright, does that make sense to you so far? Alright, so how is an angle created? What do we need? We need two what? Two rays. And where do they meet? At the common point. What's that point called? And what are the other two parts called? Right, and how do we name an angle?
Anyway.
No, not anyway. What's one way we could not name this angle? Can you think of it? Yeah, what do you think? BCA, yeah. Why can we not do BCA? What's wrong with that?
Because A has to be the starting, A has to be in the middle of both of them.
That's right. Notice that A has to be in the middle of both of them, so that's important to know how to name an angle and how to not name an angle, okay? All right, let's practice with it. Let's move down a little bit here. A little second box. All right. Let's name some angles. Okay, so draw yourself 3 rays joined at one spot with your ruler. Draw 3 rays joined at one spot with your ruler. So there's one ray. There's another ray. And here is another ray. So I have 3 rays joined together at one spot, something like that. So go ahead and draw 3 rays joined at one spot, and we will call the vertex, we will name our vertex Q. On the top ray, label the point on ray Q to P. In the middle ray, name it S, and on the bottom ray, name it R. All right, I'm gonna highlight an angle, and I would like you to name it for me. Okay, I'm gonna highlight this angle, and I would like you to name the angle for me. What would that angle be named? Write it down. If you write down that angle. Okay, who thinks they know how to say it? Yes, what would it be?
Angle RQS.
That'd be angle RQS. Or, is there another way we could name it? Angle SQR. Okay, now, someone said we could name this angle Q. Could we name that angle Q?
No.
Okay, why do you think not? You're absolutely right. Why not?
Because there's 3 rays.
Because there are 3 rays labeled with angle Q. So these ones right here, okay, those are the yellow ones. So I'm highlighting these in yellow. Okay. All right, I'm going to give you another one. I'm going to highlight that in like light blue. Okay. Okay, did everybody see the one I highlighted in light blue? Okay. Could you please name that angle? On your page, go ahead and write it down. All right, who thinks I have the proper name for the angle in blue? Yes, in the back.
Angle
Angle PQS. Is that correct?
Yeah.
Is there another way we could name that particular angle? Yes, in the front. Yes, we could say angle SQP, right? So we have 2 options for that one, so I'll highlight those. Those are our blue ones, okay? So we could say that the highlighted angles over here and over here are equal to each other. So each of those angles are equal to each other because they represent the same angle. You feeling pretty good so far about that?
Yeah.
All right, great. Do you have any questions so far about that? No. All right, cool. We are moving on. Let's go to the angle postulate theorem. The angle postulate. So for this one, you're going to need your protractor. So go ahead and get those out. And I'm going to drag mine down here. There we go. Make mine a little bit bigger. Oh. Isn't that pretty sweet? I like it. All right. So do you know how to use your protractor to measure an angle? Anybody know how to use their protractor to measure an angle? Yeah? All right, here's what I want you to do, right? On the page somewhere, I'd like you to draw an angle that looks like this. This is the third one. Okay. So just draw yourself an angle. Okay, somewhere on the page. And we'll label our vertex B. Okay, and the way we use a protractor, I don't know if it's going to work on mine here, but the way we use a protractor is we take the protractor and we line it up right over the center at our vertex. So you see how I moved my protractor right over the center at my vertex? I don't want to move it up or down. I want that little tiny hole to be at the center. Okay? See this little center right down here?
These don't have holes.
Oh, okay, we'll just put it in the center. Yeah, some don't have holes. Right at the center. So you want to line that one up parallel with the bottom side. And then you want to read off the angle that is swept out. So in my case, I'm reading up and over. Could you tell me what angle degree is measured there? About what? What's it close to? It's close to 60, right? It's closer to 60 than it is to 50. So if you had to take a guess, what would you think it would be? About 55 or 58, right?
Mine's like 50.
Yours is like 50. So go ahead and try and measure the angle that you created on your page with your protractor. So my angle was about 55 degrees. Okay? So you're going to be using your protractor to measure angles later today. And that's all there is to that one. That's it for that one. And the last box is known as the angle addition postulate. All right, I would like you to draw 3 rays connected at a single vertex again, so I'll do it with you. That's not what I want to do. Alright, so draw 3 rays connected at a single vertex again. And we will call our vertex, in this particular case, we'll call it A. I'd like you to put a dot or a point on your top vertex. We'll call that point R. I'd like you to put a point on your middle ray from your vertex. Call that point P. And put a point on your bottom ray from your vertex, and we'll call that point T. Alright? Now there are 3 angles here that we're going to talk about, and I'm going to highlight the first one for you, the big angle, okay? The big angle is this angle here, from R, A, all the way down to T. Does everybody see that big angle, R, A, T? Okay, so I'm going to write that angle down, okay? So angle, R, A, T. That is equal to, you're allowed to break up that big angle into 2 smaller angles. I'm going to show you the first one. It's going to be in pink, okay? That's going to be this angle right here. So how would you label that angle in pink right there? What would that be?
RAP.
Yeah, that would be angle RAP. Okay, now, there's one more angle. Does anybody see what it is? I'll put it in green. Does everybody see this angle down here? That one right down there, that's in green, okay? And what is the name of that angle that I just did in the green? Yes? PAT, you got it. So angle P, A, and T. Now, how can I relate those together? If it's called the angle addition postulate, what do you think I do to these angles down here? Add them together, right? And you're exactly right. So I'll highlight those angles again for you, okay? Our first one, our big yellow one, the big one, yellow on the outside, RAT, is equal to the pink one, which is right here, plus the green one, which is this one over here. So we are allowed to break up an angle into a collection of smaller angles, and that is the angle addition postulate. What do you think about that? Does it make sense to you? You're going to use it later today. And the last idea from this one, part of the same box, is how to classify angles. There are 4 major classifications of angles. Alright. 1, 2, 3, and 4. Four major classifications of angles. Okay. And they are this. I'll give them to you in words first. Acute. Acute angles. Okay. So, what is an acute angle? I think you might already know what it means. Yeah, Adrian.
An angle less than 90 degrees.
An angle less than 90 degrees. So let's draw a picture of an acute angle, right? Here is an acute angle. The space in between is less than 90 degrees. Okay? The next one is called a right angle. So right angles. So what do you think right angles look like? Yes? Not exactly 90 degrees, right? And the way we represent 90 degrees is with a little tiny box that says 90 degrees right there. Okay, so I have acute, I have right. What do you think the next one's going to be? Yes. Obtuse, very good. Obtuse angles. And what are obtuse angles, everybody? More than 90 degrees, yes, very good. So the angle, the space that's inside here, right? This is greater than 90 degrees. And finally, can you predict the last one? Yes. Nice job, Crystal. Straight angles. Straight angles, right? And straight angles look like this. Right? They go from there to there, and they create 180 degrees.